Okay, welcome back. We're looking at the function of a function rule. So the function of a function rule. So we've got question 8. These are the ones that we want to get excited about. Part A, d dx please, x squared minus 7. I'm going to do these this way. I'm going to let u equal x squared minus 7, and Leibniz tells me that that's going to become u dx. Now over here I've changed this to u, so I can't do d dx something u, so I've got to say, well, I'm going to d du u3, and that is going to be equal to something. So instead of, this is the difference between assigning y as an equation and just using an expression. So it's important that we get to do that. So du dx is going to be 2x, and this one's going to become 3u squared. Now together they form a chain for d dx. So we're still going to have d dx. It's just that we're going to go through something else to get it. And the something else that we're going through to get it is d du dx. Okay, so we can put those in. So d du is 3 squared times 2x. So that's 6x. And then we'll put a power of 2. And in there we had a u, which was x squared minus 7. So d dx of that is this result. So being able to do them as expressions, I believe, is incredibly important. Okay? So that's why I'm going to continue to do it. So I'll contrast it for you because I think that's important. So for B, we've got a bit of, let's call it y equals square root of 3x squared. Any of you would breathe a sigh of relief. Okay, let's just make that bigger. And over here we're going to say straight off d dx, the square root, that's more like the question on the sheet. Okay, so a bit of pre-work. So y is equal to 3x squared minus 6 to the power half, or if you like, d dx 3x squared minus 6 to the power half. So they're the same thing. Okay, we're doing the same thing. One's an equation, and one is an expression. So over here we'll let u equal 3x squared minus 6. And over here we can write y equals u to the half. We can write dy du. And over here we can write du dx. And that's our chain, isn't it? It's y in terms of x. So if we bring this down, y dash is equal to dy dx, dy through du dx. So we do the same over here. But this time we don't have a y. So we've just got to be sensible and pull up a d du. Okay, so we can do du dx there, that makes perfect sense. But I've got no y to sub in for this half. I can't do d dx u to the half, So I have to do d du, u to the half equals. Now this is different. See this? You put the equals after the dd, but here you put it after the expression. Please be careful. This is important. This is an important little construct. Okay? You put the equal sign after. Okay? You put it after. Alright, so we can do you can't see my fingers, but basically it's 3 seconds worth. This one here is 6x. Same over here, 6x. And this one here becomes half u half minus 1. I don't need to do anything equals wise because I have it. I already have that equal, so that makes perfect sense. Okay, so I can put an equals down here because a half minus 1 is negative a half. So negative a half is going to be, and u itself was, and we're going to multiply that by 6x. So we're going to end up with a total of 3x over the square root of 3x squared minus 6. Same thing over here. A half minus 1 is minus a half. So it's 1 over 2 square root of u, which was 3x times 6x. We'll be cancelling. So we'll get 3x over. Same. So whether you do it by expression or not is not the point. Okay? It's just not that important. Alright, you can check that with Wolfram, of course. Just do d dx and the expression, or differentiate y equals square root of 3x squared minus 6. That might be a good exercise for you to do. Alright, so that was B. Let's have a look at C. I like these. These are good for you guys, okay? These are good for you. Okay? So question 8C. d dx 1 over square root of 10. Okay, so a little bit of pre-work. And finally, d dx. Oops. Broke my own cardinal rule, didn't I? Do as I say, not as I do. And then we'll bring the negative a half up. 10x. Now we're ready. So that's the one we're going to do. So let u equal 10x plus 3. The u dx on the way to the chain rule. We can do it. It's 10. And just because I made that u, I can't do d dx u to the half, but I can d du u to the minus a half. And then put the equal sign there. So that would result in minus a half u minus a half minus 1. So minus a half minus 1. I know, I can hear you say what the answer is, but that's not the point. I want you to practice. Minus 3 on 2. So this guy becomes minus a half u to the minus 3 on 2 Not quite done yet. Remembering that this is a chain for d dx, so I can't forget that 10 at the moment. Now it's the square root of u cubed. Okay, that's the d to u part. The d dx part is the 10. The 10 comes over times the 2. U was 10x plus 3. All cubed. So we know that's going to cancel. So we get minus 5 over 10x plus 3. So there you go. That's our final one. So that's all done with the expressions. You need both. You need to do both the equation type and the expressions type. And I'm bringing it now to you because it's just needed. We just need to come to terms with it. All right, how are we going for time? Yeah, we've got a little bit of time here. So I'll add these in. So we've got D. Sometimes picking what to do with these is interesting. There's no tricks there. There's no perfect squares or anything. Okay, so we're ddxing all of that. So we're going to bring it up. So we're ddxing 3 bracket minus 1. Okay, and now we can do our that u equal x squared minus 7 dx equals 2x. We can't ddx u to the minus 1, so we're going to have to du 3u minus 1 and put the equals on that side. Okay, so that's going to become minus 3u minus 1 minus 2, which is going to be equal to minus 3 over u squared, which is minus 3 over x squared minus 7 squared. And then finally, we've got to bring in the chain rule. So our final ddx is minus, so I'm being very careful where I put the equal signs, minus 6x over x squared minus 7 all squared. So that was D. Very good. Could have left the minus 2 up, but we didn't. All right, for part E, eight E, 3 over x squared minus 7 all cubed. And we're saying, hey, differentiate this. So that means we ddx 3 lots of, bring it up, and we equal that. So we let u equal du dx equals 2x. We can't just take d dx of 3u to the minus. Okay, so we have to say let's differentiate d du. 3u to the minus 3. So they'll end up chaining together to make d dx. So that becomes minus 9 u to the minus 4 and times that by 2x now. So we get minus 18x, and the u to the minus 4 goes down as u4, and it's x squared minus 7. So that's our final answer. Alright, so I'm going to let you work through these products here. You can put them all into Wolfram Alpha for question 9. So I'll let you do that. You can put them into Wolfram. And check your work. Okay, I'll leave you to do that. Alright, see you in the next round.